Hello viewers and dear students. Today in our class we'll understand these four important laws for a perfect gases. Okay, you watch the video till end without skipping. I'll give you a memory tip where all these four laws you can just remember with four letters. Okay, so before knowing what exactly these laws are, since we are talking about perfect gases, we should know what a perfect gas is. Okay, so first and foremost point with respect to perfect gases is it should have no forces of molecular attractions. Okay, then it should obey all gas laws in entire range of temperature and pressure. For a gas to be a perfect gas or ideal gas, it should have no forces of molecular attractions and it should obey all gas laws in entire range of temperature and pressure. These are the two requirements, two important requirements for a perfect gas. Okay. Then you should know one more point, that the physical properties of gas depends on pressure, volume and temperature. Okay, so these are the three important properties for gas. Okay, the pressure exerted by the gas and the volume occupied by the gas and the temperature. Okay, you are for the first time to our channel, and if you are not subscribed our channel till now, kindly subscribe our channel. Okay, now let's see these laws one by one. Okay, first, Boyle's law. Okay, what it states is the absolute pressure of a given mass of a perfect gas is inversely proportional to its volume. Okay, provided the absolute temperature remains constant. Okay, so mathematically how we can write, the absolute pressure is inversely proportional to its volume at absolute temperature remains constant. Understood? So this, it is simply PV is equal to a constant. If we generalize this equation, we can write it as P1 V1 is equal to P2 V2, so on until n you can write Pn Vn, where 1, 2 till n are different sets of conditions. Understood? So Boyle's law states that P is inversely proportional to volume at constant temperature. Okay. Now consider one example. I'll just write a PV diagram. If we take this as pressure, y-axis, and volume in x-axis, this representation we call it as PV diagram. Okay. So initially if I take, it is P1 and V1. Okay. If we heat this gas at constant temperature, T is equal to constant. Okay. Then the pressure decreases from P1 to P2, whereas here you can see volume increases from V1 to V2. Okay, this is the PV diagram. At initially the pressure is point 1, it is pressure is P1 and volume is V1. Okay, when we heat this gas at constant temperature, then pressure decreases from P1 to P2, whereas volume increases from V1 to V2, which indicates it works on Boyle's law concept. Right? It works on Boyle's law. So, can you say the process name for this PV diagram? If you know, comment your answer. Okay. Now, let's see the Charles law. Charles. What this law states is, the volume of a given mass of a perfect gas is directly proportional to its absolute temperature, provided the absolute pressure is kept constant. So, what mathematically how we can write is, V is directly proportional to T and P remains constant. Okay, now it is V by T is equal to some constant. If we generalize this equation, we can write this as V1 by T1, V2 by T2, so on till n conditions is equal to constant. Where again here 1, 2 till n represent different sets of conditions. All perfect gases shows this property. So thus the temperature required to reduce or to decrease the volume of a gas to 0, we call it as absolute zero temperature. So, what do you mean by absolute zero temperature is the temperature required or the temperature at which the volume of the gas reduces to 0, we call it as absolute zero temperature. So, this is very important concept to solve many competitive questions, okay, like GATE, IAS and all, okay. Now, here with respect to this, we can write it is V by T is also equal to, right, where V naught is the volume at 0 degrees Celsius and T naught is the temperature, that is absolute zero temperature. So, V is equal to T V naught plus T naught. 2 you can write plus it is T V naught by 273. Okay. This is also one more important equation to solve your with respect to some competitive exams. Okay. Now you consider a graph. If I consider this temperature y-axis and volume as x-axis at say T1, say some condition 1, the temperature is T1 and volume is V1. Okay, at constant pressure, okay, if we increase the temperature, at T2, then obviously point 1 it is T1 and V1. When we increase the temperature at T2, as we increase the temperature, the volume also increases. Okay, this is an example for Charles' law. Okay, understood? Now let's see the Gay-Lussac law. Lussac law. What this law states is, the absolute pressure of a given mass of a perfect gas is directly proportional to its temperature, provided the volume is constant. Understand? Mathematically, how we can write it is absolute pressure is directly proportional to absolute temperature at V is equal to constant. Volume is kept constant. Understood? So it is P by T is equal to some constant. If we generalize this equation, we can write T1. Okay, this is Lewis law. Now we have all these three laws, right? Then what's the necessary for this general gas equation? Having laws which give some relation between pressure and volume, volume and temperature, and pressure and temperature. All combinations are possible, right? What's the need for this general gas equation? If you know the answer, just comment your answer. One thing if you observe, Boyle's law is P is inversely proportional to 1 by V at temperature is constant, right? Charles' law, it is volume is directly proportional to temperature at pressure is constant, right? Then Gay-Lussac law, it is pressure is directly proportional to temperature at volume kept constant. If you observe these three equations, the three properties of a gas, if you are taking or if you are considering three properties of gas, one of the properties we are keeping constant, right? But in actual process, these all three parameters or all these variables vary simultaneously. So there is no chance to keep one of the parameter constant. So for that purpose, we combine Boyle's law and fission. Right. Beginning of the video, I told you perfect gas properties, right? Okay. But do you think such gases exist? Comment your answer. Now, for general gas equation, we are considering Boyle's law. What it states, P is inversely proportional to 1 by V, or we can write V is inversely proportional to T. Boyle's law, what is? It is P is inversely proportional to volume, or we can also write it as volume is inversely proportional to the absolute pressure. Then what Charles' law states? Charles' law states it is V is directly proportional to T. So I call this as equation 1 and equation 2. From 1 and 2, it is obvious that V is directly proportional to T and inversely proportional to pressure. If we combine Charles' law and Boyle's law and Charles' law, we are getting this, right? So Vp by T is equal to, so this we can write here, this Pv by T is equal to some constant. So this is for unit mass, okay? This equation is for unit mass, and here Pv by T we call it as R, which is characteristic gas constant. Okay, so Pv by T we call it as R, which is characteristic gas constant. So if we generalize this equation for unit mass, what we'll get? We can write it as Pv V1 by T1 is equal to P2 V2 by T2, so on till n number of conditions, right? Where again 1, 2, n represent different set of conditions. Understood? So this we are saying it is for only unit mass, right? So if it is m kg of mass, m kg of mass, then this equation we'll get Pv by T is equal to m into R, or Pv is equal to mRT. This is the general gas equation. Very, very important equation to solve your problem, especially if you are preparing for your competitive exams like GATE, and IES competitions and all, you can definitely expect minimum one question from this topic. Okay? If you like, now I'll give you a memory tip to remember all these 4 laws in just 4 letters. Before that, if you feel this video is helpful, give a like. Let's see the memory tip. Okay? Everyone knows PVR timing, right? So everyone knows PVR timing. Right? So if you just remember PVR time, you can remember all these laws. Okay? How? I'll tell you, see. First law, Boyle's law. Okay? See, it is something which relates to give relation between P and P. Right? So you should also know that these laws depends on three properties, that is pressure, volume and temperature. This knowledge you should have. Then first, if you consider, you take this. Next parameter PV, this I done. Now I will take V and T. There should some connection between V and T, right? Here if you come V and T. Only Boyle's law is the only law which gives you inverse relation. Okay, all other laws give you direct proportionality. Okay, it directly proportional to the given parameters. So P is inversely proportional to 1 by V. This is done. It is Boyle's law. Then V is directly proportional to T. Here temperature remains constant. Here the other parameter which I left over here is, it is P, right? So absolute pressure remains constant. And final law, there should be some relation between P and T. It is also P is directly proportional to T. This is Gay-Lussac law. Here volume remains constant. See, these laws are also in, it is straightforward. P is inversely proportional to V, V is directly proportional to T and P is directly proportional to T, and the remaining parameter obviously we kept it as constant. Easy, right, to remember? Now general gas equation, you can directly write it as PV is equal to some constant into T, or PV by T is equal to constant. This is general equation. Hope this video is helpful for you. If so, give a like and share with it to your friends. Thank you. Shri Gurubhyo Namah.